Now that we know the general form of the Taylor series, we should compute the Taylor series for the three most important functions of calculus: the exponential function, the sine function, and the cosine function. So let's start with the exponential function. So we're doing the function y equals e to the x. We need to know the derivatives, but the first derivative of e to the x is just e to the x, and so on for all the higher order derivatives. So the value of 0, f of 0, which is e to the 0, is equal to 1. And then the first derivative of 0 is also 1, and so on for all of them. So all of these f's in the Taylor series are equal to 1. So then we write the general Taylor series is e to the x then becomes 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and so on. Probably the most important Taylor series in all of mathematics. Okay, after the exponential function, we should do the sine function. So let's do the second one. Will be y equals sine x. What's the derivative of sine x? Well, y prime then is equal to cosine x. What's the derivative of cosine x? So y double prime equals minus sine x. And then what's the derivative of minus sine x? So y triple prime is equal to minus cosine x. And then it repeats itself going back to sine. So if we look at the values of f, we have f of 0. Sine of 0 is 0. F prime of 0 is cosine of 0 is 1. F double prime of 0 is again sine of 0 is 0. And finally, f triple prime of 0 is negative 1. We plug into the Taylor series then, and we obtain that the sine of x is equal to, the constant term then is 0. F prime of 0 is 1, so the leading order term here is x. F double prime of 0 is 0. F triple prime of 0 is minus 1, and the next term is minus x cubed over 3 factorial. This continues, so it's x minus x cubed over 3 factorial. The next term would be plus x to the 5th over 5 factorial, and the term after that would be minus x to the 7th over 7th factorial, and so on. A very important Taylor series in mathematics. That's the, we did the exponential function, we did the sine. So the last one I want to do is the cosine. We can cheat here. So the cosine is just the derivative of sine. So we can write the cosine of x is just the derivative of the sine of x. So that would be the derivative would be 1. The derivative of x is 1. The derivative of x cubed is 3x squared. So the 3 cancels the last 3 in the factorial, or I should say the first 3 in the factorial. So it becomes minus x squared over 2 factorial. The next term then would be plus x to the 4th over 4 factorial. And the next term would be minus x to the 6th over 6 factorial. And so it continues. So these are 3 very important Taylor series that you need to memorize because they're used frequently. So e to the x is 1 plus x squared over 2 factorial, plus x cubed over 3 factorial, plus etc. Sine x has leading order term x. It has only odd powers in x. It has alternating signs. So sine x is x minus x cubed over 3 factorial, plus x to the 5th over 5 factorial, etc. Cosine x has leading term 1. It has only even powers of x, And cosine x then is equal to 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial, etc. I'm Jeff Chasnov. Thanks for watching, and I'll see you in the next video.